Hello and welcome to TelecomTV. My name is Martin Warwick. We're here at the Small Cells World Summit 2015 in London's Docklands, and I'm talking with Steve Greaves, who's the CEO of CCS, which of course stands for Cambridge Communications Systems.
Yeah.
Got it right. Steve, good to see you. Thanks for talking to us. First of all, your company, probably you as well for that matter, as the creator of the world's first self-organising and self-healing small cell backhaul solution.
Yes.
Now, what is self-organising? I can understand the self-healing, but what's self-organising?
So she's in the context of microwave systems, so it's a microwave system, it's self-organised. So it uses conventional microwave frequencies. And the idea is that, the concept behind it is that we can take a microwave system, a traditional microwave frequency band, and we can make it deployable with people with limited skill sets, so electricians, etc.
Right.
And the whole reason behind that is that if we look at small cells and the way small cells are going, dense deployments of networks, then the cost of deploying, maintaining, extending those networks is just far too expensive if you run on the conventional microwave planning route of spectrum allocation, spectrum resource allocation, microwave planning, and all that whole cycle takes a heck of a long time. So we came up with the concept of, which is borrowed from the small cell world anyway, if these things have to be viable, they have to be installed in 15 minutes. We use the kind of standard 15 minutes. Many other companies now claim 15 minutes, but we were the first, I can assure you, and we've proven that we can have somebody from Balfour Beatty, an electrician with no skill, install one of our systems, switch it on, have it figure out the best connection, backhaul connection, and be self-organised within 15 minutes. So it's a concept that enables operators to reduce the cost of deployment of these networks. That's really what we mean by it.
Right. Sounds really interesting and very different. And I've heard lots of people say anybody can do this, and then 4 hours later the bloke's there scratching his head, looking at the screen, but yours works.
Yes, ours works. And if you go to our website, there's a video of a Balfour Beatty electrician installing this in less than 15 minutes.
Interested to hear it. Right, now then, small cells have been around for quite a while and have gone through several iterations and phases. Where do you expect to see small cell technology going and evolving? That's over, say, the next 5 years, because there's a lot of talk now about the 2020 network.
Well, I see small cells increasing in density of deployment, cost reducing. I see them evolving to higher and higher capacities. We currently have sort of single carrier MIMO LTE small cells deployed at the moment, and we're backhauling them, which are around about 100-150 megabits. We certainly see networks that will be running to 400-500 megabits in the near future. And when we talk to a lot of the people out there, they're saying they need peak rates of a gigabit in the next foreseeable future, the 4 to 5 years. So we see that capacity will increase. The ability to deliver quality of service to end customers will be developed, so latency times will come down when they have to bring more time-sensitive applications. We see more and more services being run over these as the cells get closer to the end user, and that's the whole point really. The whole point is that as we densify this network, the bandwidth available to end users and end applications becomes higher and higher. So we see deployment densification, we see increase in capacity, and we see performance enhancement in terms of latency and end quality of service being delivered. Okay,
let's talk about one of the big controversies at the moment in this world. It concerns what's generically being called LTEU,
Yes.
LAA in standard speak, and it's of course LTE across the public spectrum. What's your take on it?
I think it's a good thing. I think it's a good thing because it brings more capacity for us to backhaul and there's more demand for our system. But I think in general, I believe if you have aggregation across licensed and unlicensed bands, ultimately it's better for the end user, because Wi-Fi is great, and Wi-Fi will continue to evolve, but the actual structure of current Wi-Fi networks, if you try to get high capacity over, areas like this, there's a lot of contention, there's a lot of difficulty in accessing. I think it brings a structure to the overall access to spectrum, and it's a better use of spectrum. I do believe, however, the LTEU will have to be friendly towards Wi-Fi. I still want my Wi-Fi, I still want to go anywhere and use Wi-Fi. So I think they have to work very hard on that, and we believe that that is a mandatory part of how they will work together. But in general, I think it's a good thing. I think you get a more a better use of spectrum, higher quality of service, and from our point of view, it all adds up to higher capacity required for backhaul, and that's good for us.
Can't be bad for you at all. You mentioned this, but there's one school of thought says actually what LTEU is the big telcos, the big operators, the big carriers way to get a hammerlock on unlicensed spectrum and hang on to it for grim death. While others, as you have just said, and you're obviously in the other camp, it's a user-friendly method of aggregating data to provide a better service to users. But what about that notion that the big telcos are going to keep as much of this to themselves for as long as they can?
So let's lay this scenario out.
Yeah.
We see the cost of small cells coming down.
Yeah,
okay,
absolutely.
So people like Qualcomm and Broadcom, these guys are they're introducing the technology and the software such that third parties that are not conventional big telco operators can access that technology. Yep. Now let's say I'm a kind of independent, I may even be an FWA, fixed wireless broadband provider, service provider, an enterprise business. Why can't I start to run a network using LTEU? Why do we always consider it from the sort of command position of top down? I think it could be quite a guerrilla activity. It could start people to start networks and carry mobile traffic over their networks that wasn't possible before. So you can look at it from both ends. Yes, for sure, the big operators could use it. But there's no reason anybody can't use it if they can get access to the technology. So the key thing is that access to the technology to develop LTEU networks available. And I think that needs thinking about, but I think if we can achieve that, then you get a real sort of groundswell of maybe new startups, new mobile network operators operating in regional areas because the cost overhead is much lower.
Sure.
So I think it's a situation of the glass can be half full or half empty, depending on how you view it. I can see that both could happen, but I would err to the side of entrepreneurs, which I'm an entrepreneur, latching onto an opportunity and utilising that. And I think if I was a big operator, big entrenched telco, then I might be slightly worried.
Okay, thank you. Good answer, I like that. Now, final question to you about urban small cells.
Yes.
If you remember the hype of 2-3 years ago, they were going to be everywhere.
Yeah,
Absolutely everywhere. They're not, though, are there? There's very few of them. This is what people been talking to me quite a lot over the past few days about, is the fact that they can see, unless this takes off now, it's always going to be a niche. It's never going to become pervasive and ubiquitous. Why? Because within a few years they're going to come butting up right alongside 5G, which is a different kettle of fish altogether, and can do everything that the small cells can do in the urban environment. What's your take on that?
I don't believe that you'll be able to run 5G without small cells. What's 5G about? 5G is about increasing capacity. There's potential for using millimetric frequencies in 5G. You cannot run millimetric frequencies over the same range as you run low frequencies. So the sub-6 frequency bands, they can go maybe 500, 600, 700 meters as small cells. With millimetric frequencies, the range is much smaller. That necessarily requires a small cell approach to it. So small cells will be a fundamental part of 5G. So there's no reason to say that small cells will butt up against 5G. Small cells, in my opinion, will enable 5G.
Also a very good and succinct answer. Steve Greaves, thanks very much indeed.
Thank you.